Hi, this is the second lesson on the rate of diffusion of gases. If you recall, last lesson we have looked at the diffusion rates of nitrogen dioxide and bromine in the glass jar experiments, and we have concluded that nitrogen dioxide gas diffuses faster compared to bromine gas because nitrogen dioxide has a lower relative molecular mass compared to bromine. So this lesson we will be looking at another experiment that shows us how the relative molecular mass of a gas affects the rate of diffusion. Let's watch this video.
Ammonia and hydrogen chloride gas are colourless, but when they meet, a white cloud of ammonium chloride forms. A piece of cotton wool soaked in concentrated ammonia solution provides ammonia gas. Concentrated hydrochloric acid provides hydrogen chloride gas. Place the two pieces of cotton wool at opposite ends of a tube and the gases spread out. You can compare the speed at which they approach each other by looking out for a cloud of ammonium chloride. After less than a minute, a white ring begins to form, marking where the gases meet. The white solid is closer to the hydrogen chloride end of the tube, on the right. So which gas has travelled faster? Another way of monitoring the progress of the gases is to run a piece of damp indicator paper along the tube. Hydrogen chloride gas turns it red, ammonia turns it blue. Why does ammonia travel faster?
Right, why does ammonia travel faster? Before we move on to that, let's appreciate the reaction in the video. This is the chemical reaction of the reaction that has occurred in the video. Ammonia reacts with hydrogen chloride to give us ammonium chloride. Ammonia and hydrogen chloride are volatile substances, so they vaporize easily from the concentrated solution to form gas particles. And there are high concentration of ammonia in this region of the tube, and there is a high concentration of hydrogen chloride particles in this region of the tube. So both the gas particles will try to diffuse from the higher concentration to the lower concentration at the other end of the tubes. So we have found out that the white fumes of ammonium chloride is formed closer to hydrogen chloride. And this means that ammonia would have traveled a longer distance compared to hydrogen chloride in the same time. So ammonia travel faster. And why is that so? Let's calculate their relative molecular mass. This is the relative molecular mass of ammonia, 17. And the relative molecular mass of hydrogen chloride is 36.5. From this, we can see that ammonia particles have a lower relative molecular mass. Hence, it diffuses faster compared to hydrogen chloride particles. So, by now, we can draw a relationship between the relative molecular mass of gases and their rates of diffusion. The smaller the relative molecular mass of the substance, the faster the rate of diffusion. You may pause the video as you take down this into your notes, but I will proceed on to the next section. Because armed with the relative molecular mass as well as the information on how it affects the diffusion rate, we can now tackle porous pot questions. Now, porous pot basically means a pot that has many holes whereby gas particles can pass through. Let's take a look at this question. Scenario 1. Okay, in this scenario, we have a higher concentration of air molecules inside the porous pot and a higher concentration of hydrogen particles outside the porous pot. So, according to diffusion definition, we would expect hydrogen to move from outside the porous pot to inside the porous pot, and the air molecules to move from inside the porous pot to outside the porous pot. But before we proceed on, we need to remember that hydrogen is much more lighter compared to air, so it will diffuse faster. Okay, it will diffuse in faster, and when it diffuses in faster, it will cause increased weight of the particles on the water level here. So it will push down the water level, causing it to fall initially. After a while, air molecules will start to move out as well. So when it starts to move out the porous pot, there is less weight and hence less pressure on the water level. So the water level will start to rise back up. But as we know, diffusion will result in equilibrium in concentration at the end. So once we have achieved equilibrium in concentration, the water level will then go back to X. And hence the best option will be A. Water level will fall and then rise and then return back to X. Now, using this same reasoning, let's try to tackle the second scenario. In this scenario, we now have a higher concentration of hydrogen inside the porous pot and a higher concentration of air outside the porous pot. So we would expect the air to move into the porous pot and the hydrogen to move out of the porous pot. Now, hydrogen being lighter than air, it will diffuse out faster. When it diffuses out first, it will cause less weight to be on the water level, to be exerted on the water level, and hence the water level will first rise. But after a short while, the air molecules will start to diffuse in. And when it diffuses into the porous pot, it will add weight and pressure on the water level. And this will cause the water level to fall. And eventually, equilibrium in concentration will be reached and the water level will then go back to X. Hence, the option will be C. Water level will rise, then fall and return back to X. Now, the third scenario. Could you try to analyze the third scenario on your own? You may pause the video, but I will continue with the explanation. The first step to tackling this question is to calculate the relative molecular mass of the two gases involved. Now, we have nitrogen gas and carbon monoxide gas. So, nitrogen is N2. So, 2 times 14, this number I get from the periodic table, and I will get 28. Carbon monoxide, carbon and oxygen, 12 plus 16 to give me 28 as well. We notice that the relative molecular mass is the same. So when the relative molecular mass is the same, they will diffuse in and out at the same rate. And when they diffuse in and out at the same rate, there will be no change in the pressure exerted on the water level here. So actually the answer is none of the above, because the water level will remain at X without changing. You should be able to solve porous pot questions on your own comfortably using reasoning of the rate of diffusion based on relative molecular mass. If you still have problem with it, you may go back to the video and to listen to the explanation one more time and try to internalize it. That's all we have for this lesson. Thank you.